When considering a combination of transformations, it's almost like juggling. You have to think about the stretches and compressions, both vertical and horizontal. Then you also have to think about reflections and translations. This first example starts off a little bit easy in that they've given you f at x already, and they're going to apply these two transformations. So they're going to start off easy at 2 first. Now, this is a vertical stretch or expansion by a factor of 3, and then also a reflection in the x-axis. Okay, there's no translations. Now, if we were to graph each of the different steps, we would always leave the translations to last. So you have a choice. You could either graph the reflections or the stretches or compressions first, but as long as the translations are left till last, you'll end up with the right answer. Okay, so what I decided to do was do the stretch first. Now, I considered each of the peaks and dips, okay, and I multiplied the height by 3. So since these 3 dips have a height of 0, even if I triple it, it's still going to be 0. But these 2 peaks, this one at 2 and this one at 3, are going to be tripled, and it's going to look like this. Now notice that there is no negative here because I haven't reflected it yet. So this is just a stepping stone, and once I reflect it over the x-axis, it's going to look like this. Essentially, each of your heights are going to be multiplied by -1, or you just put a negative in front of your y values, and then you're going to get that flip over the x-axis. Also notice that these previous graphs turn black. So when you're graphing all the different transformations, you want to make it very clear to the reader which one your final graph is. In fact, you don't even have to put these stepping stone equations if you don't want to. You can just put the final equation. If we had to compare the graph of y equals -3 f at x to the original, we would say that these specific transformations had happened. There was a vertical expansion or stretch by a factor of 3, and then there was also a reflection in the x-axis. Let's try transforming the base root graph again. Now, they might not give you the base root graph on a test or a quiz. You'd be expected to draw it yourself. So we know the major points, 0, 0, 1, 1, 4, 2, and 9, 3, and we can easily graph the root graph. Taking a look at the equation, it looks like there's quite a couple more transformations this time. There's 2 different reflections. There's a stretch, a vertical stretch here, and this one is going to be a horizontal compression by a factor of 1/2. And then since this guy is outside of the root sign, this is a going down transformation. Okay? So again, why don't we do the stretches and compressions first, and then we'll do the reflections, and then leave the translations to last. So the first one was dealing with this guy. I vertically stretched all of my y values by a factor of 4. So since I had 1, 1 here, it became 1, 4. And another point was 4, 2. And instead of 4, 2, I'm now at 4, 8. Okay, so I just multiplied all my y values by 4. Then what I did was I did my compression. So that affects all of your x values, and you're now going to compress it by a factor of 1/2. So for instance, this point at 1 and 4 is now going to be 1/2 and 4. And then the other one, I think it was, let's see, 4 and 8 is now going to be at 1/2 of the 4, which is 2 and 8. Okay? Let's take a look at all of the reflections now. We're going to flip it over the x-axis and then the y-axis. So I've accounted for both of them at the same time. Assume that this one, if flipped over, the x-axis would be down curving this way. And then we're going to reflect it over the y-axis, so then it would curve this way. Okay, so just to save time on some steps, I just jumped ahead and did both reflections at the same time. And the last one is, I'm going to move the whole thing down 1. Okay, so it's just shifted down 1. And that's our final graph. You could always do the mapping notation where you create the table of values on the side and manipulate the table of values and then just graph the final graph. That's fine as well. Now, how would you describe this combination of transformations compared to your original? Well, we had a vertical stretch by a factor of 4, a horizontal compression by a factor of a half. We had both the reflections and then also a vertical translation down one. Okay, so that's all of them right there. Now the third question gives you your f at x, which they said was the base graph root x. And what they want you to do now is they've manipulated f at x. Now we know that since the f at x represents a root x graph, you could always erase off this f and then put the square root sign instead. Okay, now there is one thing. Everyone's always going to think that this goes to the right 3. But don't forget that you have to factor out anything in front of the x. So the best thing to do would be first to factor. Let's get rid of that f and put the root. And then if I factor a -1 out right here, I'm left with, in brackets, -3, not a +3, because the -3 is being divided by -1. So since we thought it was originally going to the right 3, we were incorrect. It actually goes to the left 3. Okay, and then you just apply all the transformations, and we're going to jump ahead, and this is what happens. So you have a vertical stretch by a factor of 2, so all your y values are going to be multiplied by 2. Then you have a reflection in the y-axis, so this guy flips over here. Okay, and then you're going to be moving to the left 3 and up 4. So left 3 and up 4, and I'll just show you this tip right here. 1, 2, 3, 1, 2, 3, 4. Okay. The very last question is, if they gave you the original graph and they told you it was a parabola, x squared, they're now going to tell you it's expanded vertically by a factor of 5, reflected in the x-axis, and translated 6 units to the right and 3 units down. So write the equation of the new function. Let's go in order. Okay, so here's the original graph. If I wanted to expand it vertically by a factor of 5, the 5 would go in front of the x squared. If I wanted to reflect it in the x-axis, the negative would go in front of the 5. If it was translated to the right, we need some brackets then. Okay, so the -6 would go in here, and then if we wanted to go down 3, the -3 would be on the outside of the brackets. And just for an extra piece of information, if you had reflected in the y-axis, the negative would go right in front of the x, and then in brackets you would have to have x minus 6 again, so 2 sets of brackets. All right, so when you're doing a combination of transformations, there's so many different things to consider. Just remember that you have to do stretches and compressions or reflections first, translations last.